Hi, welcome to Code. This is day 32 of 100 Days of Code, and the question for today, actually, rather it would be an algorithm. So it is selection sort. So it's one of the most logical and easy algorithms out there. So we'll see the approach of selection sort in this video, and we'll try to program this as well. Okay, so for the namesake, I'll just read the question statement. Given an unsorted array of size n, use selection sort to sort it in increasing order. Okay, and the sample test case is that we are given an array of size 5 and we are supposed to sort this. Okay, so like you might know what sorting is, right? So basically it is just going to be arranging numbers in an array, and it could either be in ascending order, increasing, or descending order, decreasing order. So yeah, that basically is it. And this selection sort is quite obvious, right? So obvious in the sense it is one of the most logical things that you could think of. So if you have a set of things, right? Let us say you have a set of pencils, right? A set of 10 pencils, and you're supposed to arrange these pencils in their increasing height, right? So in that case, what would you do? One of the most logical things that you could do is find the smallest one, put it at first, find the second smallest one, put it at second place, and so on, right? So you are going to find the smallest elements available in the unsorted area, and you are going to make it come to the sorted place in the right order, right? So that is exactly what selection sort is. Okay, so if you are not completely satisfied with what I just told, just wait for a minute. We'll see with this array and you will understand it very better. Okay, so let me just rewrite this array. So the elements are 4, 1, 3, 9 and 7. Okay, so let me just put this in the box. Okay, so there is not enough space. Okay, fine. So what we are going to do is that we are going to traverse through this array, and we are going to find a number which would actually be in that place if the array were to be sorted. Okay, that statement might be confusing. I'll explain it again. So let us say we are here at the first position, right? We are here at the first position, and what would you do? In this place, you are going to find the right number that is supposed to be in this place. Okay, so what is the number that is supposed to be in this place? This is the first element of the array, and you're supposed to arrange this in increasing order, right? So the smallest element in the array should be the one that should be present at this place, right? So we are going to find the smallest element in this array, and you can traverse through this portion, right? You can traverse through the rest of the array, and you are going to find the smallest number among this, and you would have found that 1 is the smallest element here, right? And it is in this place, right? Let us say this one is I and this one is j, and you have found the smallest element that is currently at index j. Now what you are going to do is that you are going to swap these numbers. Okay, so 1 is the smallest number and you have found that it is the smallest number. Now you are going to swap this. So the array would become 1, 4, 3, 9 and 7, right? I hope I am making this clear. You are at the first position and you are supposed to find the element that is right for that position. So what you have done is that you are going to traverse through this array and you are going to find the smallest element in this array, right? It's quite simple. Finding the smallest element in an array is something that we have been doing for a very long time. So you are going to find the smallest element in the array and you are going to swap that with your first element, right? So the first element was 4 and the smallest element was 1. So we are going to swap that. Now the array has become 1, 4, 3, 9 and 7, right? So now the first position is cleared. So in this position we have the right number for sure, because it is the smallest number in the array. So this portion of the array is already sorted. So this portion of the array is already sorted. Now we are just concerned with the rest of the array, right? So I'm just going to increase the value of I. So the I pointer is going to be at here, right? The second position. Okay, now we are going to do the same process again. Now we are going to consider this portion of the array. I'm really sorry for this pop-up. So now we are just concerned with this portion of this array, right? And we are going to find the smallest element in this portion. So it's again quite simple. You are going to take this first element and are going to compare it with every other element that is present in the rest of the array, right? So you are going to compare it with all these elements and you are going to find that this element here is the smallest, right? Is the smallest. Next smallest element in the rest of the array, this is the smallest element. So you are going to take that is going to be, let us assume that is going to be a j, right? So you are again going to swap I and j. Okay, so swapping these. Don't worry about the first array. Now this is the array that you are concerned with. So when you swap these, it will become 13497, right? This would be the array. Okay, so this is the array that we have, and we know that the first two elements are sorted now, right? We have done the process for first two elements, so we know those are definitely sorted. Okay, so now we are moving to the third element in this array, right? The third element in this array. So the I value is currently here, right? I'm sorry for the interruption. So the first two elements are sorted, right? So the current value of I is 2. Okay, the index is 2 and it is going to point at the third element of the array, and you are going to do the same process again, right? So in the rest of the array you are going to see which is the smallest element, and in this case your current element is the smallest element, so it doesn't matter if you swap them or not, it is going to be the same, right? So for the next iteration you will have the same array 13497, but in this position, like in this case or in this step, the I value is going to be pointed at 9. Okay, the I value is going to be pointed at 9 and the process is quite the same. You are going to look through the rest of the array and you are going to find the smallest element, and in this case it would be 7, right? And that would be currently at j, so you are going to swap I and j, meaning you would end up with an array with the values 1, 3, 4, 7 and 9. Okay, and this process is going to be done up until you reach the end of the array, right? In this case we have just reached the end of the array, and this you can see is a sorted array, right? This clearly is a sorted array, and that is what we want. Okay, the logic is quite simple actually, right? I hope you would have got some idea about it. We are just going to traverse through this array, find the smallest element possible to the right of it, right? Meaning from the unsorted array you are going to find the smallest element, which would be the right element for your current position, and you are going to swap these. Okay, that is exactly what selection sort is. I hope you got some idea. Now we'll move to Geeks for Geeks and try to program this. Here we are in Geeks for Geeks. I'll leave the link to this page in the description. You can solve this after watching this video. So we are just going to complete this method called selection sort, and it gets array as input and the size of the array n, right? So as we saw, we are just going to traverse to this array, find the right element for every position, and you are going to place it there, right? So for traversing through this array, I am just going to use a for loop. Simple for loop, I equals 0, I less than n minus 1. Okay, it should be very clear n minus 1 because we have a nested loop inside. Okay, it would be a j loop and it is going to start from I plus 1 because your current value is I here. Okay, and you are going to see the rest of the array to the right of it, which element is smaller, right? If there is an element smaller than your current element, so the j value is going to start from I plus 1. So that is why we have I less than n minus 1, meaning that we would never reach the last element with the variable I, because j would be going there. Okay, I would never go there. So I less than n minus 1, and inside this for loop we have our j loop, right? So j equals I plus 1. because I is currently at your required position, and you're going to search through the rest of the array to the right of it, right? So j is going to start from I plus 1 and j can go up to n, right? So j less than n, j plus plus, j is going all the way up to n, right? Now inside this, I'm first going to create a variable called temp, which is going to hold the value of I. Okay, so let me just explain this. So we have this variable temp. Okay, this temp is going to have the index of our current position. Okay, current position in the sense the value of I. Okay, so we are going to traverse through the array to the right of it, and you are going to see if those elements have a value which is smaller than the value that is currently present at temp. Okay, in simple terms, we are going to take one element and you are going to compare it with all the elements to the right of it. If one of those elements is smaller than your current element, you are going to pick that one. Okay, it's a simple finding the smallest element approach, and that exactly is what we are going to do here. Okay, so if array of j is less than array of temp, you are going to say that temp is equal to j. Okay, you are just making note of that index, okay, because we are going to swap it later. So the value doesn't matter. Keeping the value is immaterial, or it is just waste. Like, you need the index to swap, not the value, and even if you had the value, you cannot find the index. So we are just taking the index of the array index of the value I, so which is our current element. We are going to compare its value with every value to the right of it. If some of it is smaller, we are going to make note of that index. Okay, so that we have done, and once it comes out of the nested for loop, you would have found one element which is smaller than your current element. Okay, so in that case, you are going to swap. So array of temp with array of I. Okay, you are going to swap your array of temp. Temp would have the smallest element and array of I is your current element, right? And you are going to swap them, and that is it. The code is very simple. Now we'll try to run this and see if it works. So the code is working perfectly fine and all test cases have passed. Hope you understood this. If you have any questions, put them in the comments and I'll get back to you. Thank you so much for watching. See you on tomorrow's episode of 100 Days of Code. Bye for now.